Hello, everyone. My name is Manish Ghosh. I am a Global Solutions Architect with AWS in the Financial Services Division. So today we'll talk about containers and the various facets of containers. What are the different container services we have to offer, and why AWS is the best place to run your containers. I will also briefly touch upon two additional services which will help you manage the containerized environment. So let's quickly begin. We have just half an hour. So why containers or why microservices, right? What is the driver here? So before we dwell on containers or microservices, let's talk about our original the kind of applications we have in the current world. Giant monolithic applications. A typical a three-tier architecture where you have a web tier, you have the app tier, and then the background database, right? uh, a typical giant monolith application. So what are the problems, right? What is the problem? I mean, this has been running for years, right? So what is the why do we think that we have to now change something from a monolithic to a microservices? So let's start with this. You know, uh, a monolithic application is very hard to scale, right? So two typical kind of scaling we employ or deploy is vertical scaling, horizontal scaling, right? So there is a limit to how much vertical scaling you can do, and there is a limit to horizontal scaling. Can you do horizontal scaling without doing an application reboot? Probably not. Very difficult to manage. So next is how do you handle component failures, right? Now it's a giant piece of code, and you have multiple classes and subclasses and this and that. The point is, even if you identify a class which is causing you the error, right? How do you rectify, right? And that brings me to the next point: slow deployment process. So imagine if you have to rectify that one class, right? You then have to go a full testing regime, end-to-end testing regime to roll it out to production. That significantly dampens your speed to market, right? And the fourth obviously is limited options, right? So now we all know that different business challenges, we can solve them in multiple ways. For example, some problem can be easily solved if it is coded in C++, right? Something else may be easier in Python, especially nowadays we talk about AI, ML, and all those things. So they are it's Python is more suited to that. But if you have one giant monolith application, right, you don't really have a way to incorporate the newer latest thinking about programming languages and different design, because it's one giant design. You are kind of stuck. So what's the solution, right? We talk about give me one second. This is okay. So we talk about microservices. So what is a microservice, right? A microservice is something which is tightly scoped. You define what service or what application function it does. It is strongly encapsulated, meaning it lives on its own, no dependencies, and it is loosely coupled. And this is the key word: it's very loosely coupled with the rest of the ecosystem, right? You have and it is independently deployable. So you can deploy a microservice independently without impacting any other microservice running in your ecosystem, right? So now what do you do to build or deploy such microservice? You use microservices architecture, service oriented architecture, and other design thinking. So, as you go from a monolith service, which we talked about earlier, to microservices, there is there's a middle step which is called mini service. Uh, you're not fully microserviced yet. I mean, you have not fully containerized all your application, but you have done part of it. That's the mini service. But for all practical purpose, right, your target state architecture should be a fully microservices driven architecture, which is the extreme right hand side. Okay, so what are the drivers to microservices, right? We touched upon some of them. One is time to market, right? It is easier to develop and deploy uh, uh, a microservices based application. Time to repair, imagine the power of identifying, isolating, and then repairing just a microservice as compared to a class which is embedded in your giant monolith application, right? Imagine the kind of efficiencies you will get, in your testing, where you only have to test that one microservice, right, rather than testing that full application end to end. Hyperscaling, right? Uh, how do you scale? How do you scale horizontally? Now, we'll talk about dockers and containers a little bit more, but the fundamental design of a microservice architecture or a container is that it is ephemeral, right? So it can come and go. If it can come and go, you can scale to to an infinite limit. Basically, it is a stateless piece of code that is running and servicing your application, and technologically independent, right? Which we discussed about a challenge where some problem may be better solved using Python as compared to a C++, as compared to a C sharp. You are now free to choose. As a developer of a microservice, you are free to choose what is best to develop, what platform you want to develop in, what programming language you want to develop in. So it creates a kind of it's like empowering your development teams. So we say containers are the best way, to build a microservices based application, right? And with that, why would we say AWS is the best place to run any containerized application? So and we'll talk about it now. We have been, obviously, these are some of the stats, just for your consideration, that we have been helping customers run hundreds and millions of containers on AWS. Our ECS platform has seen 450% growth, and we'll touch upon what ECS is in a second. But the idea here is, we have been doing that for years now. And as Andy Jassy, our CEO, says, right, there is no compression algorithm to experience. So we are the most experienced platform to run your containers. But beyond that, why do customers love to run containers on AWS? See, your containers don't exist in vacuum, right? They are serving a business function, but they also talk or integrate with multiple other services. Your container may need to talk to other services. It may need to talk to databases. It may need to talk to identity services. So if you have to manage each of these integrations by hand, that becomes a challenge. However, on AWS, all our services, right, have integration hooks. They are fully integratable with each other. So when you deploy your containers, whether using whichever technology you choose, the rest of the AWS platform comes as a fully integratable option to you. So that's a huge power. You can harness whatever we have to offer very easily. The next is the DevOps workflow. One of the business functions of going to microservices is to speed up your deployment pipeline, right? Now we in AWS, right, your DevOps pipeline is fully integrated with your container and orchestration platform. The last and not the least, security and compliance, right? The security and compliance of the AWS platform and the AWS services is fully available to you. So whether be it HIPAA or PCI or SOC 1, 2, and 3, we have services, right, which are already certified by our third-party auditors to be compliant, and you can leverage on that. So imagine going to an auditor, right, where you only have to certify an application which is built on AWS, and for certifying rest of the infrastructure piece or the platform piece, you can simply offer the auditors, the certified artifacts which are available to you as a customer on AWS. So what are the typical use cases for running microservices? Basically any application environment. whether it's a batch processing environment or an ETL kind of environment, AI ML loads, hybrid workloads. You want to test, scale test or load test your application, you can use microservices. But microservices essentially it's becoming a mainline design thinking. So what is our landscape for offering you container service? So we talked about Dockers as containers, right? But to manage those Dockers, I mean, if you're running thousands and thousands and maybe millions of Dockers, right? You have to use an orchestration platform to manage, to install, or not install but deploy to some nodes, right? So for orchestration layer, right, we offer you two choices. One is the Amazon Elastic Container Service, which is our own orchestration platform. We also offer you Elastic Container Service for Kubernetes, which is our managed service for managing your Kubernetes environment. So now once you have this orchestration service, right, you have again two modes to run. So you can run them, you can run either of these, so ECS or EKS in an EC2 mode, where you are responsible for managing the underlying infrastructure, right? You have to manage the spin up and the patching and all those stuff. Or you can go the serverless route, which is the AWS Fargate offering, and we'll touch upon it a bit later. But as a summary, these are the two hosting options. And then we have the image registry. So you can register your Dockers in an ECR, and when you instantiate those Dockers, you can pull that image and instantiate it. So let's talk about Amazon Elastic Container Service, or ECS in short. So ECS again has a data plane and a control plane. So control plane has cluster manager and placement engine. Cluster manager manages the health of your instances within your cluster. You set up auto scaling and register your instances with your cluster. ECS is then aware of the capacity you desire for your containers. The placement engine enables you to, as the name says, manage the placement of your containers. So imagine if your compute side on the EC2, if you choose the EC2 path, was you have a certain type of processors for a normal workload, but you have GPUs or Inferion kind of instances for running your AI ML workload. You can configure your ECS, in particular the placement engine, to place your AI ML jobs to those GPU slash Inferion kind of processors, and and place the regular jobs, the regular application jobs, into the regular EC2 type nodes, whatever nodes you choose. So that's the role placement engine plays. McDonald's, is a customer example who has used ECS to deliver, to speed to market. McDonald's claims to have achieved 250,000 to 500,000 orders per hour using ECS. Uh, Moving to containers has simplified their development and deployment processes, obviously leading to a much faster CI/CD deployments and pipeline. ECS has obviously offered them out-of-box integration with other services they want to integrate with, including AI/ML. Monitoring is something which comes natively with AWS. But McDonald's is not just one example, right? Okay, so I had another slide, but anyway, there are numerous other customers who are using ECS. Let's quickly talk about EKS, and then I will show you, the comparison, or how would you choose between ECS and EKS. So let's talk briefly about Elastic Container Service for Kubernetes, right? So what is Kubernetes, right? Kubernetes, we all know, is an open source container management platform. It can run your containers at scale, but it is a very, very popular container orchestration platform, which customers are using. And you may be using Kubernetes in your data center environment as well, right? So the point is, Kubernetes is something which is open source, supported. It is maintained by CNCF, and the interesting part is, where you run your Kubernetes matters, right? You can run Kubernetes anywhere in any cloud provider, but the quality of the cloud platform, right, is the key to your quality of applications, and is the key to the user experience that you get, right? If the quality of platform, and when I say quality, it is the reliability, it is the scalability, right? Those are key concerns when you're running applications which are supposed to scale. According to CNCF, right, 51% of Kubernetes workloads run on AWS today. So it's a very popular way of running Kubernetes. You can run on EKS. A little bit deep dive on EKS. So again, in EKS you have the control plane and the data plane. So you manage the data plane, and we manage the control plane. kubectl, as we know, is the command line option to managing your Kubernetes environment. EKS is fully certified by CNCF. So let's talk about the control plane. So in the control plane, right, there are a couple of services that run for EKS. Two of them actually are uh, the API server and the HCD. So HCD is the key value database which manages which holds the state of the Kubernetes cluster. And API server, as we all know, is the front end to managing, or front end for all commands. So all the kubectl commands you give go through API servers. The interesting part here is, as you see in your screen, each of those, API server is managed in its own auto-scaling group, and HCD, it's managed in its own auto-scaling group spread across multiple zones. So imagine so there is no single point of failure for your control zones. Now, when it comes to the data plane, right? Uh, okay, so we'll talk about data plane a bit later. Let's talk about updating your Kubernetes versions. So since EKS is a managed service, right, we manage the updation or the patching of the control plane. You are still responsible for managing or patching the data plane uh, if you're running in the EC2 mode. Since authentication and authorization are two distinct ways to handle in Kubernetes, on AWS, we handle the authentication part using IAM, and the authorization part in EKS is handled by the RBAC on your parts. Quickly talk about worker nodes. You have a choice of different instance type. You can also use spot instances. Now, spot instances are instances which you use and where you leverage the spare capacity AWS has. So there are multiple cost-saving constructs in AWS. One of them, the basic one, is on demand. You basically pay for what you use. The other one is reserved instances, where you have to commit some amount of consumption. The other type is the spot instances, right? Where you can deploy a spot instance, and you can get the spare capacity discount, which is generally 70 to 80% as compared to on-demand pricing, with the caveat that it has to be preemptible. So and containers by design are ephemeral, right? So spot instances and containers are like literally married for each other, and you can deploy those containers on spot instances and get like huge discounts on your compute costs. You can bring your own OS. You can run whatever OS you want, especially in the EC2 mode. You can bring your own OS because you are managing those instances on your own. You can run AI ML workloads with the EKS. You can, as I said, right, you can use some of the specialized EC2 instances. You can even run TensorFlow on EKS. EKS networking. I'm going a little fast, guys, because I'm running out of time. But EKS networking, it is supported by our partner called TIGERA. They support the networking part within the EKS pods. For the load balancing, EKS supports all three types, meaning application load balancer, network load balancer, and the now deprecated classic load balancer. So how are our customers using EKS, right? They are using EKS obviously for microservices, but also for platform as services. You are not just running a compute engine on EKS. You are actually running machine learning, and you're actually running your enterprise applications on EKS, on Kubernetes, on EKS, on AWS. These are some of the examples, or these are some of the referenceable examples of customers who are running Kubernetes on AWS. As you can see, it spans multiple type of businesses, from finance to education to retail. This is another example, but I will quickly go further because I wanna. So this is just an indication of how or where to start. I will strongly point out to go to this https://eksworkshop.com. It's a self-driven EKS workshop which anyone can go and run. Right, I highly encourage you to go and run that workshop to get more detail about how you can run things on EKS. So now that we know that we have this offering between ECS and EKS, right? How do you choose which one to use? So the point is, right, if you are just starting out in the container space, right, you don't have any other experience with using any other orchestration platform, ECS is the way to go. ECS is because ECS is natively written for AWS, and it gives you very tight integration with other AWS services. It's very easy to onboard an application using ECS. On the other hand, if you had, you were running Kubernetes or in your on-prem environment, right, and you want to continue with that learning, obviously you have spent time and effort to learn Kubernetes on your data center. You can simply use EKS, and you can either create or migrate apps on EKS, or you can run the new pods on EKS. AWS Fargate. As we discussed, right, without Fargate, or meaning if you're running either ECS or EKS in the EC2 mode, you are still responsible for managing the underlying infrastructure. That includes, patching and upgrading OS, installing agents, and managing the placement of the pods. With Fargate, it's a serverless, right? What it means is that you don't have to worry about that undifferentiated heavy lifting of managing the underlying infrastructure. That is done for you by AWS. So in AWS Fargate, you don't have to manage the underlying EC2 instances. It is fully elastic service. It will go up and down based on what you require, and it is fully integrated with the rest of the ecosystem, AWS ecosystem, including VPC networking and load balancing and IAM and whatnot. So the idea here is, with Fargate, right, you can just bring your existing code and deploy it on Fargate or in a Fargate mode on either ECS or EKS, and be up and running. It is production ready. It is fully compliant with different compliance standards, and it is fully integratable with other AWS services. These are some of the benefits we already talked about, right? There is no need to manage or patch the underlying instances. So how will you decide whether to run in the EC2 mode or in the Fargate mode? So if you have a requirement where you want to control the placement of pods or placement of your containers onto specific instances, right? You want to manually control that for some reason, you would probably go with the running in the EC2 mode. if you don't care, right, if you let AWS take the decision, you can run with Fargate. Also, many a times, especially in the financial world, you may have a security requirement where your security team may want to have direct access to the underlying EC2 instances, right? In that case, you would have to run with the EC2 mode. You cannot run Fargate because we don't allow you SSH into the underlying compute. So this is another example of a customer using EKS and Fargate. So let me quickly go and give you a flavor of these two new services. One is AWS Cloud Map. Obviously, it is not new anymore. It was introduced last year. But what it does is that it gives you a service discovery platform for your container landscape. So you can deploy your services, right? And how do you manage those services namespace? You can use Cloud Map to manage the namespace for your application. The next is App Mesh, which is AWS implementation of Service Mesh, essentially a tool deployed to manage the observability and the network traffic control. So what we deploy is we deploy a sidecar pod into your environment, and that manages the observability of your application. And we obviously have a rich partner ecosystem across the board, whether it be foundation or DevOps or security or networking or monitoring and logging. And with that, I'm just a minute over, but thank you. Thank you so much all for listening.